Okay, let's unpack this. If you're building software, you kind of know the drill, right? You're handed these complex problems, maybe a messy pile of specs.
Yeah, and somehow you've got to turn all that into something that actually works, is clean, reliable.
Exactly. It's way more than just writing code, isn't it? It's really about how you think through the whole mess.
Absolutely. It demands this like constant effort to figure out what's really going on, sort through the noise, and then, find a way forward.
Right. And this deep dive is all about tackling that head on with two skills that are just essential for developers: critical thinking and problem solving.
hmm We've been digging into these excerpts from a developer's toolkit that really zeroes in on these areas.
So our mission here is to really explore what the toolkit says these skills are, understand why they're so important in coding, and crucially, look at a couple of practical frameworks from the source that you can actually use.
Sounds good. Where should we start? Maybe with the definitions.
Yeah, let's kick off there. How does the toolkit define critical thinking for a developer?
Well, it frames critical thinking as the ability to objectively analyze and evaluate information or an issue to form a sound judgment.
Okay.
It's less about instantly having the right answer and more about the process.
Yeah.
Questioning assumptions, spotting potential biases.
Making sure you're looking at things from different angles.
Exactly. The key traits highlighted are logical reasoning, being genuinely open-minded, and basing conclusions on evidence, not just like gut feelings.
Okay, so that's about understanding the situation systematically. What about problem solving then?
Problem solving, according to the toolkit, is this systematic process you use after you've analyzed things. It's about identifying the core problem, analyzing its roots, and then actually moving towards a solution.
Right, getting things done.
Yeah, and this involves creativity, resourcefulness, but also structure. Key things here are root cause analysis, brainstorming effectively,
Yeah.
and refining your approach as you go, iteratively.
Got it. So one helps you really see the landscape clearly. The other gives you the map and the tools to navigate it. And the toolkit's pretty emphatic. These aren't just nice to haves. Why so critical for developers?
Well, software problems are often just inherently complex, aren't they? Requirements can be fuzzy, systems interact in unexpected ways. Critical thinking lets you cut through that ambiguity just to figure out what the real problem even is. And problem solving gives you that structure to break down a massive challenge.
Into manageable bits.
Okay.
And I bet that feeds directly into code quality.
Oh, absolutely. Making reasoned decisions about, say, architecture or algorithms, or even just picking the right tool. That all stems from solid critical thinking. It leads to more efficient, more robust code.
Makes sense.
And the toolkit also points out how vital these skills are for teamwork. Integrating different views, handling feedback objectively. It all relies on these abilities.
Plus, tech changes so fast. You're always learning, adapting. Being able to critically size up new tech or pivot when something isn't working seems essential.
Totally agree. Now, the good thing is the toolkit doesn't just define these skills. It offers practical ways to build them. One classic framework it covers is the 5 whys.
Yeah, the digging technique, asking why
Yeah.
repeatedly to get past the surface symptoms down to the actual root cause, usually like 5 times.
Exactly. It sounds simple, maybe deceptively so, but it's powerful. The toolkit gives some good software examples, like a system outage after a feature deployment.
Okay, walk us through.
So, 1, why did the system go down? A buggy configuration was deployed.
Right.
2, why was the configuration buggy? It wasn't tested properly in staging.
Okay, classic.
Why wasn't it tested in staging? Well, there wasn't a defined process for testing config changes. 4, why no process, or why wasn't it followed? The team wasn't actually aware this level of testing was needed for config changes.
Lack of awareness.
Why weren't they aware? The documentation didn't clearly specify it.
Wow. So you go from a technical glitch, the bad config, all the way back to a gap in documentation and process. The root wasn't the bug itself, really.
Precisely. It was the system around the code. There's another example in the toolkit about a system crash. Why? A memory leak.
Okay.
Why the leak? Code wasn't releasing memory. Why not? Developer didn't follow best practices. Why didn't they? Lack of code review or oversight.
And the final why.
Why is the lack of review?
Yeah.
The team was skipping code reviews because of, tight deadlines.
Oof. That one hits home. Again, the root cause isn't purely technical, the memory leak. It's the external pressure leading to skipping a crucial quality step.
Yeah, the toolkit really drives home that these process breakdowns, especially under pressure, are often the real underlying issues.
It really shows how systemic problems often are. Okay, shifting gears a bit, the toolkit also introduces Edward de Bono's 6 thinking hats. That's another framework.
Right. This is the one where you metaphorically put on different colored hats to force yourself or your team to think from specific viewpoints.
Yeah, like white hat for just the facts, data, information, red hat for feelings, intuition, emotions.
Black hat for caution, risks, what could go wrong. Right. Yellow hat for optimism, benefits, the upsides. Green hat for creativity, new ideas, possibilities.
And blue hat is kind of the meta hat, controlling the process, managing the thinking itself.
Exactly. It's designed to ensure you get a really comprehensive 360-degree view of a problem or situation. Yeah. The toolkit uses improving an inefficient bug tracking system as an example.
Okay, how would that work?
Well, you start with the white hat, gather the data,
Yeah.
how many bugs are we logging per week, average time to fix. Then red hat, capture the team's frustration, maybe user complaints. Black hat, what are the risks? Are we missing critical bugs? Is the interface confusing? Yellow hat, what are the potential benefits of improving it? Faster fixes, happier developers and users.
Then green hat is the fun part, brainstorming.
Yeah. Maybe ideas like a totally new user interface or using machine learning to prioritize bugs automatically. And finally, the blue hat structures it all. Okay, what have we learned? What ideas should we explore? What's the plan?
It forces you out of your usual thinking patterns. You consider the data, the feelings, the risks, the potential, the new ideas, all in a structured way.
Right. The toolkit shows how this leads to, much richer discussions and ultimately more well-rounded, effective solutions.
So pulling this all together then, critical thinking and problem solving, they're not just abstract ideas floating around.
Not at all.
As these developers' toolkit excerpts show, they translate into really practical tools, like the 5 whys for digging deep and the 6 thinking hats for making sure you look at problems from all sides.
And mastering these, as the material really suggests, directly boosts your effectiveness, whether you're wrestling with a stubborn bug on your own or trying to improve a team process.
Yeah, and thinking back to those 5 whys examples, it's striking how often the toolkit points to the real root cause being not just a technical slip-up, but some kind of breakdown in process or communication, especially when things get busy.
That pressure element is key.
It really is. Which kind of leads to a final thought, maybe something for you listeners to mull over, stemming directly from these examples. How can you or how can your team actually build in safeguards? Habits or processes that protect that essential critical thinking and problem-solving time. Things like doing thorough code reviews or proper testing, even when the deadlines are tight and everyone's feeling the pressure.
That's a really important question. How do you shield those crucial practices?
Something to think about.